Welcome to the Neurologic podcast, coming to you from the UT Dallas Center for Vital Longevity, which is dedicated to pursuing research that leads to cognitive health for life. Our goal is to educate you on the latest matters relating to cognition and the brain, and with each episode we will be interviewing leading scientists and sharing their insights and suggestions to promote cognitive health throughout the lifespan. My name is Amber Kidwai.
And my name is Sarah Munir.
And this is Neurologic. In this episode, we meet with Dr. Charan Ranganath, a distinguished neuroscientist and psychologist and New York Times best-selling author. He is a professor at UC Davis, where he directs the Dynamic Memory Lab, and his research delves into how memory is influenced by factors such as emotion, stress, and aging, and how it's affected by neurological disorders like epilepsy, stroke, schizophrenia, and Alzheimer's disease.
And you may be interested to know that beyond academia, he is also a songwriter and a guitarist.
His recent book, titled Why We Remember, is a New York Times bestseller that gives a fresh perspective on our understanding of memory and how it impacts our learning, decision-making, recovery from trauma, and our ability to heal emotionally.
So in our conversation today, Dr. Ranganath explains something surprising. Forgetting isn't always a bad thing. In fact, it's something our brains are actually designed to do. So think about it. If we remembered every little detail of every day, it would be hard to focus on what really matters.
We also talk about the role of attention in forming memories, and we go over some strategies that we can implement in our everyday lives to help us remember important information.
One of the big takeaways from our chat is that memory isn't like an instant replay of the past. It's not perfect. Our brains piece together things, and sometimes that leads to mistakes like misremembering something we saw or heard.
That's why memory can be tricky in situations like eyewitness testimonies in court cases. We also dive into topics like curiosity.
Have you ever noticed how you remember fun facts you were curious about way more than the boring stuff?
And we also explore the role of sleep in memory and how it strengthens memory. We know stress is bad for us, but did you know it can impact your memory too? Dr. Ranganath helps to break down how things like rest and stress affect memories and how they are formed and stored.
We really enjoyed our conversation with Dr. Ranganath, and we're so excited to share his insights on memory and cognition. Through his pioneering work, Dr. Ranganath continues to shape the field of cognitive neuroscience and memory research, and we're really grateful to him for sharing his expertise with us today. We hope you enjoy this episode. Dr. Ranganath, thank you so much for joining us today.
Thank you.
So before we begin, can you tell us a little bit about your background and what got you interested in memory research?
Okay, well, my background is I grew up mostly in California, did my undergraduate at UC Berkeley in psychology after a brief stint as an electrical engineering major. Then I went to graduate school in clinical psychology at Northwestern University. And so memory research wasn't quite on my radar. I did volunteer in Art Shimomura's lab as an undergrad, and Art was a major memory researcher at the time. I was doing clinical psychology and I was doing depression research. But we had kind of interesting combination of events where my advisor, who was doing who was doing depression research, left and got a job at Stanford. And so about halfway through my grad school time, I had to find a new advisor. And it just so happened at that time I was getting really into cognitive neuroscience because brain imaging was really taking off at that time. PET scanning was big and fMRI was just getting off the ground. And we had this new researcher named Ken Paller who joined the department who had done PET scanning, which I thought was amazing. And I kind of talked my way into kind of squatting in his lab and then sort of osmosed in and became a member and then started doing memory research.
So you recently published your book, which I have here, and I read in preparation for this, and it's basically a fascinating deep dive into understanding human memory and how it shapes who we are. The book is titled Why We Remember. But one of the interesting things that you touch on in the book is actually why we forget. And I feel like when we talk about memory, we often focus on why we aren't remembering as much as we feel we should. But you point out that considering how much information we receive on a constant basis, it's surprising that we actually remember anything at all. So could you explain to our listeners why, as you put it, we're actually designed to forget?
We already know that we don't even perceive much of the world that's actually out there, right? We feel like we do, but in fact, there's all sorts of things that happen that we're not even aware of, right? But even that information that gets in, it's been shown that we lose a massive amount in a short amount of time. So within 20 minutes, you could lose 40% of the details of your experiences, right? And by the end of, 9 hours, you could lose 80% of those details. And I defy anyone to tell me all the details of everything they've ever experienced on any given day. So it just doesn't happen. And so the idea that we should expect to remember everything doesn't make any sense, really.
So it's evolutionarily advantageous to forget and have more of a selective memory rather than a perfect memory?
I think it's evolutionarily advantageous. I also think it's computationally advantageous. I think that most of our experiences are not worth keeping around. It would be like hoarding, right? So you could say, well, isn't it better to just keep everything that you've ever touched than to actually, throw things away and so forth? And the issue is, of course, if you just hoard all the things that you've ever owned, then you just end up with a bunch of clutter and you can never find what you need when you need it.
Not to mention when you're actually remembering, every detail, it's going to be so slow to bring it to mind because you have to go through every single detail that you remembered. So the processing speed would be much slower in humans if we're remembering every single detail. That's
right. And it's also the way memory works in the brain is that you have similar sets of neurons encoding multiple memories. And so what that means is that the more memories you form, the more competition there is between memory, between different populations of neurons. And so to some extent, the more you learn, the more you will forget. It's actually a computational principle called the stability plasticity dilemma, which is basically kind of saying, well, if you make your brain more plastic, then your memories become very unstable. And so, which is kind of a counterintuitive thing. Everybody thinks, oh, more plasticity, this is great. And it's actually not true at all. It's we're at a pretty optimal level of plasticity for the most part.
Right. So it basically makes us more efficient thinking machines.
Yeah.
Like the fact that we can forget.
Absolutely. Because otherwise you'd have a bunch of information that you couldn't use when you need it because it would be too slow, too error prone.
So one of the reasons that we forget is something called interference. So could you kind of explain what is interference and is there anything we can do to reduce it? Is it even a bad thing? What can we do to prevent it if it slows us down?
Well, most of the time when we talk about interference, it feels like a bad thing because we're not remembering something that we want. And so that's usually what people are talking about. Although clearly it's just the way the system works, neither good nor bad. So interference is when you have two memories that overlap in some way. And so you can think of it like if a particular memory comes up because a particular set of neurons, which we call cell assembly, if this group of neurons is active and you have a particular memory, well, what if there's an overlapping memory that has many of the same neurons as a part of it? Then there's a competition as to which one can come up at any given time. So just as an example, people sometimes have trouble remembering where they put their keys, but the problem isn't that you don't remember any place you've ever put your keys, but where did I put my keys 1 hour ago as opposed to 2 hours ago, or in my case, it could be 30 minutes ago, right? So there's all this competition between all these different memories that could come up. And so interference can work at one level, which is simply finding the memory you're looking for. And that's how psychology research typically describes it. So for instance, if I have a very cluttered desk and I'm trying to find a password I've written somewhere, then it's going to be very hard to do so if I have gobs of clutter. And this goes back to our earlier point. But if I've got like a very empty desk and there's just one note there, it's very easy to find. So we can think of the cluttered desk as an analogy for interference, right? That we have a clutter in memory. The memory's there, we just can't find it, right? There is, though, another way of thinking about it, which is that when you have competition between memories, it could actually lead the memories themselves to be destabilized. So traditional view in memory research is that interference is just not finding the memory you're looking for. But in fact, that competition might actually degrade memories. And we don't really know because the animal research doesn't give us a great way to look at that question, in my opinion.
So with interference, like you mentioned, the clutter desk example, how does attention and intention play a role there to kind of help combat this interference? So you've talked a lot about, for example, the prefrontal cortex, how it plays a role in helping us stay focused and intentional about what we remember. So how exactly does the prefrontal cortex support memory, and how does this change as we age?
Yeah, it's really interesting because for a long time, people didn't know what the prefrontal cortex did at all, or they didn't think it did anything really. And so that's why they did frontal lobotomies in the 60s. Bob Knight, who's a researcher who does research at UC Berkeley, would always tell me that people used to think of the prefrontal cortex as the airbag for the brain because it's this big chunk of tissue that's in the front part of the brain. Now everyone knows how important it is. But even now, but especially back in the 60s and 70s, all the papers and chapters that would be written about the prefrontal cortex, they would say the riddle of the frontal lobes or the mysterious prefrontal cortex, and everything just emphasized what a mystery it was because it wasn't necessary for seeing things for the most part, not necessarily for saying things or, perception or motor function. It's really more about this higher order thought. And it really is about the ability to translate your goals into focused perception and focused action. So it's easy to think, okay, well, I want to go to work today because I want to make a salary, therefore I should be able to go to work. But if there's a bunch of other stuff competing for, what you could be doing at a given moment, that's going to be hard for you to do unless you have the prefrontal cortex, which is basically saying, look, I know I could be grabbing my guitar and playing for another hour, but I have this appointment that I have to do, and it's important because I don't want to let this person down. And so it's allowing you to say, hey, I've got this goal that's not in front of me. It's not going to be something that I'll get for a while, but it's important enough that I should just suppress what's immediately grabbing to me. So in the case of memory, what happens is we have all of these things that could be competing for our attention, right? So you walk home, maybe the TV's been left on, maybe your dog starts barking at you and so forth, and then you lose track of where you put your keys because there's just so much stuff happening that's grabbing your attention. And so we talk about intention as being the ability to focus your attention on what's relevant to you at the moment. So for instance, if you say, it's important for me not to lose my keys or not to leave my keys in the door, which I've done, unfortunately, more than I would like to admit. It's important for me not to leave my keys in the door. So I should focus my attention on where I'm, on the literal feeling of holding the keys and everything that's going on around me at this moment and not get caught up in the dog and not get caught up in the TV and not get caught up in my head, which is where I end up often thinking about other places and other things.
Right. So the prefrontal cortex really helps us narrow down our focus on exactly what we want to do and helps us stay on track of our tasks.
That's right. That's exactly right.
So what about an older adult? So I know that older adults tend to have eventually some degeneration in these frontal areas. So how does attention work with them, and how does that affect, for example, the interference that we talked about?
On average, memory gets worse, episodic memory, that is, our memory for events. It gets worse as we get older. And one of the things that we know is that that's partly because of changes in the functioning of the prefrontal cortex. It becomes less efficient, and there's all sorts of reasons for that have to do with biological changes at many levels, right? But what happens is a number of studies have shown that sometimes older people can have trouble remembering the information that they're trying to remember, and they get random memories for things that they shouldn't be remembering, essentially the things that are irrelevant. So there's a great series of studies by Lynn Hasher, who studies memory and aging, and Karen Campbell is the other person. And they've done work on what's called hyperbinding, where older adults will sometimes grab on too much to information that they should be shutting out in mind. And so that's one reason. Another is interference, because if you have your attention start shifting around too much, you don't really form memories for particular events or instances or items or whatever. You don't form memories that are very clear and focused and specific. Your memories become very blurry. And so your memory of where you put your keys 10 minutes ago is so vague because you were shifting around in your head thinking about all these things or getting distracted by other things in your environment that you really formed a very fragmentary, blurry memory for putting down the keys, right? And so that's another way in which the prefrontal cortex really comes into play, is helping you do that during learning. And then also to be able to help you sift through the information and search, come up with a strategy for how can I find my keys later on. So it's so important at every step, and that's why when you get older, you struggle so much more.
Right. That makes sense. So kind of staying on this topic of attention, I know you've kind of been open, I think you mentioned in your book about like ADHD, and I know that's like a very common struggle a lot of individuals face these days. So how does, experiencing ADHD affect this interference and recalling information when trying to form these long-term memories, especially when there's that competing information like we talked about?
Yeah, it's interesting. So what I would say is that it basically, ADHD is a problem not of attention per se, but rather of intention. It's about cognitive control, your ability to regulate what you're supposed to be doing or what you are doing based on what you feel like you should be doing, right? And so what can often happen is that we end up like getting shifting our attention too easily, or we get stuck. So this may be a little bit of a digression, but there's this sort of an optimal level where you want to be in the brain, where your thinking is stable enough so that you can stay on task, but then you want to be able to shift your focus when at the right times, right? So in other words, it's like, I want to get a cup of coffee, and once I get a cup of coffee, now I want to shift my focus back to going to the podcast interview or something, right? And so you want to have that balance of stability and flexibility, and that balance gets thrown off in ADHD. And so what happens is you can be, on the one hand, very bored and restless and fidgety and shifting too much, and then you can fall into a zone of hyper-focus where you're just stuck on one thing and you can't get out of it. And so it's a problem in both directions.
So I wanted to bring up something that happens to me literally on a daily basis, which is walking into a room and forgetting why I went there. And this is something a lot of people, especially middle-aged adults, worry about as being an early sign that their memory is going. But you describe this as normal and say that it has something to do with event boundaries. So could you tell us exactly what event boundaries are and what this means for memory?
Yeah, so to fully get it, it's important for people to understand that our episodic memories they exist because we can ground our experiences to a particular time and place, right? So in other words, if we just focused our memories purely on content, there would be no way of remembering where I put my keys 20 minutes ago, because I put my keys in so many places that those memories would overlap too much. So episodic memory is this really clever solution where it says, I don't really know what's going on here, but it happened at this place at this time. And so that's what we call context. And so episodic memory is not organized by content. It's like what happened as much as it is by when and where and how it happened. Now, the thing is that in normal experiences, our context is fairly stable for periods of time, but then it changes. So we're in this room, and this room is our context. It's very stable right now. But if I were all of a sudden to take a bathroom break and run out, now what happens is my context changes dramatically, because as soon as I walk through that doorway, now my whole visual world is different. My sense of where I am is different. And so what happens is that now I have to go back in time and travel to what happened in here in this room to figure out why did I leave the room in the first place, right? So if we were to go to the kitchen and be like, okay, I left my phone in the kitchen, I walked into the kitchen, if I've crossed through a couple of rooms, my sense of mental context has changed. And so I arrived there, and whatever I was keeping in mind before I left the room is now gone because that mental context shifted so much. And so what I have to do now is do this really hard bit of episodic retrieval to be able to say, I imagine, what was I doing in that room? What was I doing? And sometimes you have to actually go back to the original room, and then you say, oh, this is what I wanted.
That cue is over there.
Yeah, because then once you're in the right context, then the memory just pops right up.
No, that's definitely happened to me too, Amber. You're not the only one. So we kind of talked about the prefrontal cortex and its importance in memory. Many of us are also familiar with the hippocampus when it comes to memory. So it's a small structure located in the temporal lobes, which is near your ears. But although the hippocampus plays a key role in memory, there are so many other regions involved that don't get as much attention. For example, in previous episodes, we've touched a little bit about something called the default mode network, which includes areas of the brain that are active when we're not actively doing a task. So often it's linked to self-reflection, daydreaming, and mind-wandering, things like that. So you've mentioned that the default mode network plays a specific role in memory. Can you explain how that works?
Yeah, and I should say that this is my view, and there's lots of other competing views on this. And I should also just credit that I hadn't really thought about the default mode network until I actually had a random conversation with Mick Rugg, who's at the center here, and he actually got me thinking about this. And I don't think he likes any of my ideas on this topic, but he probably regrets that conversation. But the people called this network the default mode network because the original thinking was, well, if I ask you to do something, well, now the activity in these brain regions goes down. And so what they said is, Marcus Rakel, who came up with this term, he came up with this idea that maybe this network of areas is on by default, but then when you do something, now this network shuts down. And that was largely because the imaging studies that were being done of that time used really dumb tasks. It's just like, does this contain a letter A, or is this a verb or a noun, or just things like that, right? But if you think about reasoning, you think about navigating to the grocery store and planning your shopping list. You think of imagining how you could write the end of your paper. All of these activities are incredibly attention demanding and, consuming of energy, right? And yet they're associated with the default network. So the default network is not at all about disengaging from a task or something. In fact, actually, I think it's absolutely crucial for goal-directed behavior. But it's about disengaging from the external world and getting more into your head about a model of what's going on in the world, and creating a little model in your head. So we talked about event boundaries, and one of the things that we've seen in our imaging studies is in the default mode network, there's a pattern of activity that would stay pretty constant while you're in one event, like if we're sitting here in this conversation. And then if all of a sudden you just picked up your phone and started texting people, I would see a big abrupt shift in my default mode network as I'm trying to make sense and create a new model for why is it you're on the phone right now? Oh, she's checking messages. And so those shifts are actually associated with event boundaries, because I go, one event is over, we're no longer talking, now she's checking her phone, and that's where this flip would take place, right? And so what we believe, and I think there's really good evidence for, is this idea that the default mode network isn't dedicated to episodic memory or semantic memory or any of these kinds of terms that memory researchers throw around, but it's really about being able to pull up organized knowledge to generate a model of what's happening at a given moment.
So I was going to ask, does that relate to schemas?
Yes, yeah. So basically schemas are these organized knowledge structures, fancy way of saying we have knowledge about certain classes of events, right? So For instance, it's like and everybody, for whatever reason, uses coffee as these examples, and I'm looking at a coffee cup, so I'll go with that. So you walk, I want a cup of coffee, so I walk into a cafe. I don't have to figure out why people are in line. I know why people are in line because that's what you do before you order a cup of coffee. You have to wait in line. And if I go in front of all these people, then they're going to get mad at me because that's not how this works. Likewise, I can give money to the cashier or, pay with my credit card, and they will leave me with nothing. But I know I will get my coffee because that's how these events work. So a schema for events can be thought of as being like a sort of a little mental model of the cause and effect kind of structure of what happens when you go to a cafe. I know if I give this person money and I say I want my, double non-fat latte, whatever thing, half cap, decaf thing, whatever.
Specific order.
Yeah, exactly. Whatever it is, you put in your random Starbucks order or something like that. You know that there's going to be a person who's going to give you that coffee later on. The barista is going to do that, right? And that's what gives you the faith is that you've seen this through many, many similar experiences, or sometimes even one experience can be enough to create these schemas, right? So the schema can be something that's very abstract about what usually happens. And then during one particular event, we can think of that as just being one instance of this larger broad category of things. So sometimes you can go to a cafe and maybe they get your order wrong or something like that. But that's a little path of things that could happen in a cafe, right? Yeah. So I hope, does that answer the question?
Yeah, totally. Yeah. So basically, like, knowledge of what has happened kind of helps us predict the future.
Thank you. That's exactly what I should be saying. Yes.
No, you totally make sense. So great.
So one of the big breakthroughs in memory research was the realization that memory shows similar brain activity to imagination. But that's because memory is considered to be more of a reconstructive process rather than just an exact replay of prior events. And you describe it in your book as being more like a painting than a photograph, where the painter may embellish some things or focus on certain details. So since we are reconstructing memories in the moment, how is that affected by our own biases?
Well, it can be quite significantly affected by our own biases and our own beliefs. And it's a good thing that we do encode memories this way, because essentially, and our work is really showing this lately, that the brain is very judicious and economical about what gets encoded into episodic memory. And if information is highly predictable and redundant, it doesn't get encoded. And the reason is that if you can get just the novel, surprising, important bits and pull up just those details, it's very easy to make a story and reconstruct most of what happened. But you're absolutely right that when we generate these stories, we come in with beliefs and goals, and that leads us to shape a narrative in a certain way. And so you can think of this like there's all these studies of people who like are fans of different football clubs, and they watch like a football, it's a soccer, but if we want to be European, we'll say football. So you have different football clubs and your fans, and the two teams play against each other, and the fans will literally leave with two completely different stories about what they just saw, even though they saw the same game. And partly that's because they're choosing information to pull from memory based on their beliefs about what should have happened. And then they're putting together the story about what happened based on their beliefs about the players and about the teams. And often that has to do with self-serving desires, right? I mean, people tend to believe what they want to believe, or people tend to remember what they want to believe happened as opposed to what did happen.
So what are the implications of that for things like eyewitness testimony or questioning of people that are suspected of committing a crime?
Well, I tend to take a middle ground here. It's kind of like the lukewarm water approach as opposed to hot or cold on this. Some people will say, well, you can't trust eyewitness testimony at all because memory has such an imaginative component. Mm-hmm. And some people will say, no, we remember things exactly as they happen. And those are two very distinct traditions in memory research. One is that we should focus on the constructive, imaginative elements of memory, and another saying we should just literally treat memory as a regurgitation of the past. And neither view is completely wrong or right. What we see is that people can be extremely good, for instance, at saying whether or not a person was at a crime. Like an eyewitness can often be very accurate at saying this person was there. But people can also generate very wild, incorrect stories. And there are two key factors, at least. So one key factor is just purely expertise. So, for instance, we know that there are all sorts of problems when people are trying to identify a stranger of a different race, that the effect size of people's misidentifications is quite large. And part of it is it's not really well explained by things like implicit bias and stuff. A lot of it is simply people don't look for the right information. They're literally seeing features that allow them to say this is what this person's race is, as opposed to this is who this individual is, right? And so that's a part of it. But let's say you do have the expertise and you get a really detailed memory of who was there, right? Well, later on, now you show me a bunch of faces of other suspects. One of those suspects looks kind of like the person that you saw, but not really. And so you say, well, I'm not sure. Maybe that's the person who I saw. It kind of matches. And then you see that person again when they do another lineup. And now you do remember having seen that person, but you didn't remember that from the original event. You remember that from the first lineup. And there are real cases where people were put in jail because of this sequence of events where a memory almost becomes inadvertently implanted in a suspect, because the more they're asked about it, the more information that was suggested by the questioner gets lumped into a person's memory.
And they start having this feeling of familiarity.
Yes.
Because they've seen it before, but not at the scene of the crime.
Yeah. Or, eventually you can recollect something. You can recollect, hey, I remember specifically that I saw this guy, but you remember that you saw this guy because it was in lineup, but not because you actually, and so that's what researchers would call a source confusion, where you remember something, and it's quite vivid and confident because there's a memory there, but you're creating the wrong explanation for where that memory came from.
So you mentioned that 1 in 3 people can be convinced that they experienced something that never occurred. So how can we tell the difference between a real memory and a false memory?
I credit a lot of this, what we know about this topic, to Marcia Johnson, who was one of my former advisors. And Marcia, back in the days where people were just seeing memory as this repository of stimulus response associations, she said, how do we tell the difference between memory and imagination? So she created a problem that nobody really knew existed. And it turns out it's very hard, because these are just things that come up in our heads, and we have to tell the difference between whether or not those things came up in our heads because we thought about it or because they actually happened. Like for me, it's always, did I send that email, or did I just think about responding to the email and then get distracted before I actually did anything?
Yeah, me too.
You conflate thinking about doing something with actually having done it.
Yeah, that happens to me so many times.
Yeah, and it's very hard. And what it requires is a minimum of 2 things. One is giving yourself time to actually thoughtfully process the information. So if you just respond automatically and you're trying to get things over with very quickly, we'll often fail to differentiate between imagination and reality because they're so similar to each other, right? But the second part of it is that we know that our lived experiences are going to be associated with more rich, vivid, distinctive memories than ones that are things we've thought about. So if I remember an experience of going to a restaurant, I will have some kind of memory of the smells and the tastes and the sights and the sounds. But if I just think about, oh yeah, it would have been great if I could have gone to this restaurant, I don't have that. I just have information that I thought about, maybe some emotions or something like that. And so the external details that you pull up are very important for telling the difference between imagination and reality. Now, the problem is that some people don't actually report having much of that, sensory detail when they remember things. We're just learning about this, and nobody really, I have yet to see a great explanation for why this happens or what it means exactly. And other people have such a vivid imagination that they can imagine things and it's almost as if they happen, and they have trouble differentiating between imagination and reality. So there's never a guarantee that you'll get it right, but more often than not, most people do. We don't confabulate for the most most part.
Yeah, and then also I know, like, we kind of touched on, but with age, like detailed memory declines. Like older adults have a tendency to kind of retrieve more gist-based or general knowledge. So I'm wondering if, like, with age, does it become harder to differentiate imagination and memory? Do we know anything about that?
Yeah, definitely that ability to do reality monitoring, which is to say, is this real, or did this really happen, or is this something I've thought about? It declines with age, and that's because the prefrontal cortex is so critical for this ability to say, hey, wait a minute, let's hold our horses here. My goal is to be as accurate as possible, so let me make sure that this is something that I read in from a news source that I trust and not from my wacky uncle's Facebook feed,
Exactly, yeah.
Yeah, I can see how that could make you more susceptible to things like fake news and misinformation and that kind of thing. You kind of get that type of groupthink type phenomenon as well, where everybody, like the football
herd
club
mentality.
Thing
I don't know if it's called herd mentality.
You're kind of seeing things from your own perspective or from your group's perspective and kind of falling into that.
Yeah, and if you're just kind of like, you don't have a whole lot of time and there's something that you want to believe, it takes a lot of cognitive control to overcome that and to try to remember something accurately. So you might have a little bit of a sense of a mental itch or a conflict that goes, this doesn't seem right, but if you want to believe it, that's what people will do. And I'm sure that's a real problem that we have right now, is that people don't have a lot of time. They're faced with too much information, and it's just easy to go with what we want to believe. I've actually ignored my social media feeds when anything's suggested, because they almost always tell me something that sounds too good to be true.
It's kind of that perfect storm, right? Because we do all have less time. We do all have a huge amount of information coming at us, and then we have algorithms kind of emphasizing that even more. So,
exactly. The algorithms are literally telling us what we want to hear.
Maybe 40 or 50 years ago you probably listened to the news once a day for 30 minutes and that was it, and then you had all day to ponder about what, what you thought about it.
And if you think about just the ability to separate truth from non-truth, familiarity is a big cue for that. So if you're constantly getting a flood of misinformation that tells you the same thing, it will seem more true. Even if it's not, even if you don't think it's true, it turns out research shows that people are much more likely to be willing to share fake news if it seems very familiar to them, and even if they know it's fake, which is just mind-boggling to think about.
But also the sharing part makes me think about with false memories, how you mentioned that if it comes from somebody you trust, so if someone you trust is sharing this news with you, then you're even more likely to believe it.
That kind of reminds me, I think there was like some research done where like the more familiar the face is, the more trustworthy they're deemed. I mean, this is kind of a separate topic, but that kind of reminds me of that, like how familiarity can really like distort your reality.
It's just a kind of a feeling that you have that something is easy to think about, right? And that could be a face, it could be a name, it could be a concept. And the thing is that we can. That feeling can be really manipulated very easily, and to say, oh, well, this person seems nice, well, because they're, or this person must be famous, or this, this product must be better than this other product, right? And it's kind of like how many people would, all things being equal, choose Planters peanuts over a brand of peanuts that is from some supermarket brand they've never heard of. Nobody really knows where these peanuts come from.
But we've seen it so many times. And we just grab it.
And that's why you look at like the Super Bowl advertisements, and they're not like, it's not like nobody knows what Budweiser is, right? But the Budweiser isn't trying to make their name known. They're trying to just boost the familiarity of that name so much that there's just a little bit more of a preference you'd have for that than for Coors or whatever.
And then attach the famous familiar faces to it and that kind of stuff.
Exactly. They're manipulating us. So another thing that you've touched on in your book is how curiosity can enhance memory. So can you explain how being curious can help us remember better?
So this was work that was done by Matthias Gruber, who was a former postdoc, and now he's in Cardiff University in Wales. And what Matthias was interested in is the idea that we have drives to get rewards, right? That we have our brain systems like dopamine, energize us to find things that are rewarding for us, like food or something if we're hungry. And the idea was, well, maybe those same neural systems also give us a motivation to seek information. And so dopamine, which is involved in seeking rewards, is known to actually not only energize people to get rewards. It's not actually associated with pleasure. It's associated with that drive to get a reward, and actually also to learn about the reward and how you got it, right? So the idea that Matthias has, well, maybe when we feel that itch when we're curious, that's the brain stimulating us to seek the information that would be satisfying that itch, just like you'd be seeking out a reward, because information has value too. I mean, yes, it's true that if I know, where food is, I can go get the food, but it's also nice to know, if somebody can tell me something about where to hunt or where to find the food, now I've got a lot of information that is even more useful in the future, potentially, right? So that's where curiosity can help us. And so one of the key findings from Matthias's research is, if you ask people a question and people are very curious to find the answer to this question, the more curious they are, the more activity there is in circuits in the brain that actually process dopamine. And these are circuits that are often associated with reward, but it's not about reward in this case. They're actually just getting a question. They're not even getting the answer to the question. It's just the question itself. And the more curious they were, the more activity there was in those areas. And when people were curious, they were unsurprisingly better at remembering the answer to those questions when we taught them. But more importantly, they were even finding it easier to learn information about unrelated things. We would show them a face while they were waiting for the answer. And it turned out people were better at remembering the faces that were shown while they were in the state of high curiosity. So what we think may be happening is that there's this burst of activity in this dopaminergic circuit that makes your brain a little more plastic and allows you to take in information that's both relevant to what you're looking for, but also stuff that happens to just be around what you're looking for.
Yeah. So how does this tie into attention? So I know when I'm curious about something, I kind of tend to have more of a focal attention on that thing. Mm-hmm. So could attention be that key factor that's linking curiosity to memory?
I think it's a key factor. I think that so there's a related construct, which is arousal. And so we know that people, like when people are in a high state of motivation, whether it's, threat or reward or whatever, you're going to have more arousal. You'll just feel a little more wired, and it focuses your attention. But it doesn't just give you more attention, it focuses your attention in a particular way that makes it more selective to the things that are more important to you at that time. And so in that sense, yes. But there also seems to be a plasticity benefit that you get where, like, essentially when you have neuromodulators like dopamine that are released, they can make it so that the memories you form are more likely to stick around later on. They call it consolidation. And I think that this ability of dopamine to both change attention and change and jack up plasticity are both key parts of the story.
So kind of staying on the same topic, you've also studied how novelty impacts memory. Why do we tend to remember new or unusual events more vividly than routine ones?
Well, this is also related to the dopamine hypothesis. Essentially, there's research showing that when an animal is put in a new environment that they haven't been in before, there's a big increase in dopamine activity in the hippocampus, and that actually promotes memory for information that's associated with that context. And so, and this is part of, I think, a bigger principle that I've been really pushing lately, which is that the brain is going to be very selective in promoting memories for things that are important. So what's important? Well, if I'm in a new place, that doesn't correspond to anything that matches well in memory. So I should prioritize that because it's new information, right? Likewise, if something's surprising, if it's not new per se, but it's coming up when you least expect it, that is something that you should be prepared for in the future too. And so novelty, I think, is a very important factor in determining what information should be memorable to us. And it's associated with the neuromodulators that promote memory. And So that's a big part of why we're thinking, things that are either new, surprising, or emotionally significant, that should be where the action is. And one of the things that we found in some of our recent research that hasn't yet been published is that when there is surprising information, for instance, you're, let's say, reading a comic strip and it's a new thing you haven't read before, but it's really the ending that's very surprising. Like in those old Charlie Brown cartoons, they would have Charlie Brown would go to kick a football, and then at the last minute, Lucy would pull the football away and he falls down, right? And you don't see that until the fourth frame. And so we have less funny versions of these kinds of cartoons. And what we found is that when there is an unpredictable ending, as people learn about these comic strips, what happens is that in the hippocampus, we can see a signal that we can decode that reflects people's ability to predict the ending before it happens. So the idea is that initially people don't know what's happening, and then something unpredictable happens, and the hippocampus encodes that. And then rather than regurgitating everything that happens, which is kind of the assumption that we often get stuck in, is that somehow I should just be remembering everything moment by moment. What happens is, it's in our data, it suggests that the hippocampus is deploying what you need when you need it, and giving you, okay, something surprising is about to happen, and I'm going to spoil it for you. Here's what's going to happen. And it's not giving you the stuff that happened up till that point. It's giving you the information that you need to navigate what's going to happen in the future.
So it kind of helps us like with prediction.
Prediction, yeah, exactly. And I think sometimes people get stuck in this idea that prediction should be the same as memory retrieval. But I think it's different in the sense that at least a useful system for prediction should be more goal-focused and more strategically important, as opposed to just regurgitating everything you've seen before.
So we've all heard that sleep is good for memory, but what exactly is the mechanism there? What is the brain doing while we sleep that helps us remember?
Well, there's so much that happens during sleep, and so much of it's so controversial. Yeah. I'm probably a little bit of a free radical in this debate. But we know that there's a number of things. So one is there's a lot of just housekeeping in the brain that happens during sleep. So, for instance, amyloid gets flushed out, which is a protein that's associated with Alzheimer's disease. So this and other metabolites get flushed out in the glymphatic system during sleep. And so that's one thing that we know right off the bat. But there are also all these stages of sleep that happen, like where you're in deep sleep and you're just completely knocked out, or you feel that way. And then like there's REM sleep where you're having these vivid, intense dreams and so forth. And so the brain is doing things in all of these states. So even though it feels like we're dead to the world, our brain is actually very active. And some of the new research suggests that, in fact, we may even be having some kind of conscious dreams that happen even during the deepest stages of sleep, and much more prevalent than we ever thought throughout sleep. And so what that means is that there's this whole, it's kind of like Severance, the TV show, where it's like you have like this whole other part of yourself that you just don't remember any of those activities when you wake up.
Yeah, that is so true. We're like completely different beings in our sleep.
Yeah, exactly. So what is all that about, right? If brains are doing all these things, what does that mean? What's the purpose? So the old explanation, well, I should say it's quite popular in neuroscience now, is that sleep is about stabilizing the memories that we've formed in the previous, earlier in the day. That's just called consolidation, confusingly, because people talk about, use the same word for many different things. Yeah. But they talk about sleep as being part of this ability to say, okay, well, I tried to learn these Spanish words yesterday, and now I'm going to stabilize those memories for that, right? But there's a couple of problems with that. So one is that it assumes that every memory is just independent of everything else. It's kind of like the idea that somehow we have these photographic memories of the world, and they're all stored independently in our phone. And that's not really how it works. It's this whole ecosystem of overlapping memories. So how do I stabilize one memory without affecting other things that are related to it, right? So this idea that somehow you can target like one memory without affecting anything else doesn't make sense to me. And in the sleep literature, what you tend to see is that there's a lot of variability in whether sleep seems to promote memory for, like, they'll have people, let's say, memorize a bunch of words right before they go to sleep. And it's not clear whether sleep is just kind of like slowing down, forgetting because you're not having interference.
Yeah, I was going to bring that up. I heard about the interference.
Yeah.
So I think they've talked about, like, it can be even just meditation.
Yeah.
So you're resting. Yeah. So you're trying to, like, minimize, like, other inputs that are coming in, and that can help with the interference of affecting the memory.
Yeah. And that's got to be part of the story. Although it's a little tough to, when you really start getting into this stuff, it becomes like a very, like, kind of messy web of explanations, because when we've seen in some of our studies, and other people have shown this too, that even in offline waking states, like, let's say if you're certain kinds of meditation, memories can be reactivated just like they seem to be in sleep. Now, the difference is in sleep, there's all these massive neurochemical changes that are happening. They're very different to wake, and your state of consciousness is different. So it's really unclear exactly what happens. But what we do know is that that there are certain kinds of things that seem to be very clearly affected by sleep. Motor learning is one. So the ability to, like, learn skills, for instance, that seems to improve during sleep. And there's other really interesting work suggesting that when you're trying to, let's say, learn new words, sleep doesn't just help you retain the memories of what you learn, but rather it makes it easier to produce those words in a sentence. So in some ways, what it may be doing is it may be taking these experiences and making it more usable and actionable, because there's a difference between knowing a word and being able to use it in the context of a conversation, right?
Yeah.
And that seems to be something sleep really benefits from. So a lot of it seems to be kind of pulling together the structure of many different experiences that you've had. And that's another factor, right, is that we have, like, let's say I could meet you on 4 different occasions and have 4 different contexts for having talked to you. Well, I've got 4 different episodic memories, but how do I get any sense of, what to expect the next time I see you? Well, sleep can allow me to just free associate and pull up one memory and then use that to get another memory and use that to get another memory. And now you can take things that happen at different times in different places and put it together and see if there's a big picture that you can get out of it. And that's how I suspect, and we have a computational model of this, and Anna Shapiro at Penn has a better computational model of this, suggesting that may be a big function of sleep, is sort of taking these experiences, throwing them at the wall, and then seeing what sticks. And that's how you build semantic memory out of all these individual episodes.
Yeah. So kind of integrating knowledge.
Like this general knowledge of the world and stuff.
Yeah, exactly.
Yeah.
And, if you have these context-specific memories, those contexts are like, the event boundaries are like literal walls between these experiences. And so you need some way of being able to overcome those walls and build bridges between those memories.
That makes sense. So how about stress? How does stress affect our ability to remember things, and what can we do to mitigate its impact?
Well, so stress has a bunch of different effects on memory, and people are still trying to understand it. There are all sorts of unknowns. So, for instance, it is very likely that the effects of stress are different for men and women. And for women, we don't know enough about men's hormonal cycles to know anything about that. But there do seem to be different effects of stress on memory depending on women's menstrual cycles, but also use of contraception can change stress effects on memory. So there's a whole chemical world out there that's very confusing. The general story that's come out of research is that stress, on the one hand, leads to the release of neuromodulators like glucocorticoids is the technical term, but you can just call them stress hormones. And these stress hormones promote plasticity for information, for experiences that happen while the hormones are released and then also right before those hormones are released. So an easy way to think about it is you just had this time where you're a cave person, you walked into a cave, you see a bear, you hide from the bear, it's super stressful, and you leave. And your memory can be consolidated so that you've got a very good memory that you saw this bear, but you also remember how you got there and how you escaped from the bear. And so you've got all this useful information about the stressful experience that allows you to avoid the bear in the future, right? Because if you just remembered, I saw a bear, that's not very useful to you. You could end up making the same mistake again.
Yeah.
So that's where stress can be sort of helpful. Where it can hurt you is that stress tends to downregulate the prefrontal cortex, and so it makes it actually really hard to recall information that you previously learned. So often people end up choking under pressure because they can't remember the things because they're not able to use the prefrontal cortex. And so if something's not very automatic and very really well learned, they have trouble pulling it up.
So is it like at the encoding stage, the learning part, like if the stress is too high, it can affect the future retrieval of that encoding event?
Well, so this is an interesting one because stress can improve encoding, but and this is where kind of we can't think of memory as being like one blob, right? It's like stress can improve memory encoding for the information that's most important and relevant to the stressor. But it can hurt your ability to focus on other things that you might need to be thinking about because you've got the stress, right? So it's like you're stressed out about having to go to jury duty or something like that, and so you will have trouble encoding information that's not relevant to those thoughts, right? And so that's a part of the problem. And then there's the part of the problem, which is when you're trying to remember if you're stressed, then you can't search, and so retrieval gets really messed up, and that's pretty much that happens for sure. But then there's another factor, which is that there's sort of transient stress, which we all need. We all need to have a little bit of changes in our arousal patterns to be able to remember.
Yeah, I was going to say, like, for example, like when students are studying for an exam, these kind of low levels of stress can really help you retain that information and learn it. So in small doses, stress can be very helpful for learning and memory.
Yeah, and we have some data showing that it's like, in fact, there's this kind of what they call an inverted U function, where it's like when people have too much stress, it actually like blows up their memory consolidation, and so that seems to be a part of it. There's also what happens when people have chronic stress. So like kids who grow up in abusive homes, for instance, where there's just lots of volatility, or people who are in combat and they spend days and days in these situations where they're under threat, and what you see is a dysregulation of the stress response, so that now there's kind of this chronic state of stress and hypervigilance, and that leads to all sorts of changes in the prefrontal cortex and the hippocampus that just kind of blow up memory functions so that memory can be less context specific, and that may be part of the cascade that happens in PTSD actually.
So you're not in that context anymore, but those memories are getting activated.
They're getting activated because your memories are less selective to a particular context.
Yeah.
So do you have anything you do that to help your memory?
Not enough, I can tell you that. Writing this book has kind of forced me to walk the walk a little bit more than I used to. So I really started taking my cholesterol seriously. Yeah, I mean, a lot of the stuff for brain health, as a memory researcher, I find very boring and depressing to talk about because it's so nothing that I actually study, but it's super important, all the physical health and mental health things. So
whatever is good for your heart is good for your brain.
Exactly. Well, I mean, I think it's like people tend to think of physical and mental, and really the brain is where those two come together. It's like the mental activities happen because of the physical brain that you have and vice versa. And there's all sorts of interesting things that people don't think about, like the brain consumes energy. And so if you have cerebrovascular disease, that's going to blow up the brain's ability to get the energy to suck up, excess neurotransmitters, and that will change the whole regulation of excitation in the brain and just produce all these cascading effects, right? So I'm trying to do things like, improve my cholesterol levels because South Asians have just terrible cholesterol issues, and I'm trying to do more physical exercise, things like that. I'm trying to reduce the number of distractions that I have around me and really control my environment much more. In general, I think the best thing to do, both with ADHD and just in general with aging, is you don't want to have to rely on trying harder. You want to actually make life easier for yourself by reducing the demands of cognitive control. So if I can just put my phone in do not disturb mode, or restrict my ability to click on shortcuts for, remove social media apps from my phone so it takes more work, put speed bumps on the things that I don't feel like are a good uses of my time, and then that can keep me more present and help me be better at remembering. So those are some things I do. I'm also pretty judicious about taking pictures and taking pictures in ways that help me remember as opposed to hurt.
So it kind of serves as a cue for you.
Yeah.
When you look at those pictures, it kind of brings back the memories and details.
Yeah.
That's a good idea.
Yeah. I also try to make decisions based on memory. I try to say to myself, okay, well, do I want to take a vacation? It's a pain in the ass planning vacations. It costs a lot of money, blah, blah, blah. But then I'm like, at the end of the year, will I want to remember doom scrolling on the New York Times, or will I remember sitting on the beach and, snorkeling with fish and, hanging out with my daughter and my wife?
Yeah.
It's just a no-brainer, right?
Right, exactly.
So I wanted to end on a really interesting perspective which you have about memory, which is that each stage of life has a different purpose, and our memory at each stage is doing exactly what it's evolved to do. So could you tell us more about this?
Yeah, so I got this from I was inspired on this by listening to an interview with another researcher who's doing developmental psychology research, and it got me thinking about why is it that every memory researcher will tell you that, well, episodic memory is pretty bad in children. And then when you reach young adulthood, it becomes okay. Then, you hit 30 and your memory starts declining, right? So we have this golden period of about, 5 to 10 years where memory seems to be functioning the way we think it should. Well, maybe that's not what it's about, right? And so we know that children tend to learn differently than adults. For instance, they tend to, at least in most of human history, children were learning through play and exploration. They're not sitting around in class being told, here, memorize this, memorize that as much, right? And so it makes sense to have a brain that's fairly exploratory and unfocused. And the prefrontal cortex is not functioning, and cognitive control is not functioning as well, in early childhood as it does later on in adulthood. But then the weird thing about humans is we live long past or at least we can live long past our reproductive years, right? So from an evolutionary perspective, why? If you're not reproducing, you might as well not exist. And so humans are one species that have these long lives. Elephants are another. Orcas are another. And one of the things that you see is that as people get older, again, they start to lose their goal focus. But I started to think about this as maybe when we get old, it's not about forming my own memories, but sharing the semantic knowledge that I've acquired over the years, sharing my wisdom, right? And the cool thing about that is that that's what happens with aging, is that episodic memory goes down, but your semantic knowledge is very well preserved. And people become more optimistic as they get older on average. I mean, I can think of lots of exceptions to that. We'd probably think of lots of scientists who are exceptions to that.
Yeah, they're not happier.
Yeah, but on average, people do. They become more socially focused on relationships and so forth. And I think that this idea that, maybe the brain is designed to say, well, okay, you're alive. It's not about you anymore. It's about your kin. It's about the others, the community around you. And that's how most societies have worked, I think, throughout human history. And we just have created a strange one right now where people are told, well, you're old, you can't do anything anymore.
Yeah, I think that's very much a part of just more Western society where you're kind of everyone expected to be stuck in that phase of productivity.
Yeah.
Whether it's reproducing or just productivity in society. But I like how you kind of said that, it kind of makes sense that, young adulthood, you do need to remember all those details because you're living your life that way. But as you get older, the details aren't as important, and it is more the wisdom, like you said, that you can share with everyone else and support society that way.
Yeah, exactly. And if you look at these other species like orcas, for instance, I mean, they're led by the postmenopausal females. So, which, in America, arguably, postmenopausal females are not treated very well,
exactly.
But they're teaching the pod about here's how you hunt, here's how the language works, and they're running the show. And I think that's a pretty good example of why it makes sense to have a memory that works a certain way as you get older.
Yeah, I love that perspective. So for our listeners who want to learn more about your work, where can they find more information?
Well, I have a website, charanranganath.com, where I talk about, there's links for information about my book, but also events and so forth and things that are in the works. I have an Instagram page, which is @thememorydoc. Or if you just search my name on Instagram, you'll find it. You'll also get the name of like this Tamil film actor. So it's like, you have to tell the difference, but it's not that hard.
Awesome.
Yeah.
All right. Well, thank you so much, Dr. Ranganath, for sharing your research with us today. It was such an interesting and insightful conversation. So thank you.
Thanks a lot for having me. It's a fun conversation.
Thank you for listening to Neurologic, a CVL podcast. If you like what you're hearing, please follow and share with others. This podcast wouldn't be possible without the support of our team and the incredible work that goes on behind the scenes. We'd like to give special thanks to Patricia Moran for editing this episode. To learn more about the Center for Vital Longevity, just look up cvl.utdallas.edu, and here you'll find information about our research as well as information on how to volunteer to participate in our studies and how to donate to support innovative research to understand, protect, and enhance the vitality of the mind across the lifespan. Join us next time as we continue to explore the latest research and strategies for keeping our brains healthy throughout our lives.